Now we have another eminent speaker, Dr. M. Sharmila Kumari. Here is a brief introduction. Madam obtained a BE in Electronics and Communication from MCA Hassan and University of Mysore in the year 2000 and MTech in Computer Science and Engineering from NMA-MIT NITTE VTU, Karnataka in 2004. During 2001 to 2, she has worked in Department of Computer Science, Mangalore University as a lecturer. Since 2004, Madam has worked as a lecturer, senior lecturer, assistant professor, associate professor, and currently working as professor, head of the department, and now in charge vice principal in Department of Information Science and Engineering in PA College of Engineering, Bangalore. That's really a good achievement. Madam received her PhD degree in 2012 in Computer Science and Technology from PG Department of Studies in Research in Computer Science, Mangalore University, Mangalore. Specialized in pattern recognition, image processing, embedded systems, microprocessor and computer architecture. Madam has published more than 65 articles in international and national level journals, conferences, chaired sessions in national and international conferences, successfully completed a collaborative major project with Moscow State University, Russia, and also an international workshop on emerging applications of computer vision in Moscow State University, Russia. Currently executing another collaborative major project sponsored by Department of Science and Technology, Government of India, and Russian Academy of Science, Russia. Madam has received projects from ACT to modernize the laboratory in Department of Computer Science and Engineering, PA College of Engineering, Mangalore, under MODROP scheme. Madam has served as a reviewer to many renowned journals of elsewhere, Springer, IEEE. She is a recognized guide in computer science and engineering under VTU and currently guiding research students towards doctoral degree. Apart from academic and research activities, Madam has an administrative responsibility, currently working as the vice principal of the college, served as LIC member of VTU, worked as a member of board of examination of Mangalore University, VTU, and many other institutes. Madam, the dais is yours. And I am very proud to say that I and Sharmila Madam worked together during our PhD days.
Research colleagues.
Research colleagues.
Thank you, madam, for your nice introduction. Good afternoon to all present here, respected organizers of the Faculty Development Program, coordinators and participants. Firstly, let me congratulate Department of Computer Science and Engineering, JSS University, Mysore, for conducting such an useful faculty development program that is very much required for research scholars as well as research supervisors too. So my heartfelt thanks to Dr. Bharati for giving me an opportunity to share my thoughts, whatever I acquired during my research duration as well as while guiding my students, PhD students. From a week, so you all attended various sessions that is started from biometrics, unimodal, multimodal, then all related to then various multimodal based systems developed using from conventional machine learning algorithms as well as used now the well-known deep learning concepts. So today's session, my supervisor as well as professor from Mangalore University, Department of Computer Science, so he was elaborately explained as well as given clear idea about deep learning algorithms. So that is used for both unimodal as well as multimodal biometric systems. To maintain the continuity, so let me start with introduction about biometrics. So all of you know now by this time, so everyone familiar with biometrics. So it is a field, so that is it aims to identify or recognize a people or individual based on the characteristics they have. So here, this concept, biometric concept, it was thought before 2005, but popularized after 2005. So now 2017 onwards, all these transactions, payments through the smartphones using biometric trades. So now what our industry people, industry experts, they predict, so by 2023, all smartphones are having multimodal based scanners, that is built-in multimodal scanners. So we know this is taken, these most popular biometric trades are taken from, it is a courtesy of our well-known, that is #1 researcher in the field of pattern recognition and image processing, Dr. Anil K. Jain. So we know these are the various popular biometric characteristics, that is fingerprint, face, iris, voice, hand shape, so retina, palm print, 3D face, as well as gait, IR hand, dental radiograph, IR face, ear shape, signature, keystroke, and multimodal biometrics. So why I am reading all these? So you know here, most of the biometric traits are already explained by various experts. Okay, that is why let me concentrate on the last one, multimodal biometrics. Before that, let me tell you there are two types of biometric traits, that is behavioral as well as physiological or biological. It is also known as biological biometric traits. So you know, no need to mention once again, that is physiological traits are, biometric traits are iris, fingerprint, example I am telling, ear, DNA, vein print, face, as well as behavioral, voice, gait and signature. Dr. Bharati worked on this signature biometric trait. Dr. Nagendra Swami sir worked on gait biometric trait. So similarly, my research students, they are working on fingerprint, iris, face as well as multimodal biometrics. So where we could find various applications, so we could see the most popular biometric recognition systems. It may be a 2D or 3D face recognition system, iris based recognition system, or a DNA based person identification system, or ear, fingerprint, voice, hand. So all these biometric traits are used to identify a person or individual. So what I am trying to say here, see in this, we are concentrating on extracting the feature vectors, that is discriminant features from these biometric traits. So that is, those are why we are going with extracting key points or discriminant features, because existing available systems are that memory is limited earlier. Now it is sophisticated systems are available. We are not at all worrying about space. We are worrying about now accuracy. So morning Dr. Hemant Kumar sir, he was mentioning, rightly mentioned here. So now we are not at all worrying about the speed, because such a sophisticated systems are available. Only so every researchers are in their research, they are trying to improve the accuracy. So why biometrics? So you know here, so this your password, so that can be stolen by others or forgot. You may forget. Or see here you can see I have written these biometric traits are unique, stable and natural. So why this cannot be transferred to others, right? This cannot be replicated too. As well as biometric traits, so it gives multi-level authentication. That is, authentication is strong, that is next level authentication will be there. So various applications we could find, say in the first case, face recognition system, finding missing person or cops identification. Here majorly fingerprint we are using as a biometric trait, or criminal investigation, here multimodal as well as face, or sometimes unimodal systems, either face or fingerprint can be used. Computer login, electronic payment, ATMs, record protection, passport control, border control, access control, because you people are already aware of all these things. That is why I am just moving a little bit fast. So here either you can go with unimodal system or multimodal system, biometric traits. So we have seen all these biometric traits. So always we are having, so even I got that doubt. So what are the major biometric traits are there? So that is why, so then when I gone through the literature, so I could find, so other than the additional information also you people are also having, it is my experience I am sharing. So I found this fingerprint, face as well as iris are the most popular biometric traits used in most of the biometric based systems to identify a person. So here, so let me tell you that the fingerprint verification system, so in some cases, some applications or some challenges are addressed using fingerprint biometric trait. Some cases only face. Face is why we are always prefer fingerprint and face. It is ease of access as well as always that structured environment will be there when you capture image. But in case of iris, we never get structured environment. People are not ready to expose your iris whenever we are ready to capture. They never give. Okay, they are not cooperating. So that is why. So here are some cases. As our Professor Anil K. Jain, he was arguing in some of the applications, face, he is not at all encouraging some applications, face biometric trait to recognize a person. So for example, in case of identifying the twins, so it is interclass similarity. So two different persons, right? That face, almost it is similar or same, but it is human vision system fails to differentiate. So which person, person 1 or person 2, then how you train the system? In that case, so we go with fingerprint. Okay, so here in iris, so why we go with iris biometric trait? So here in this case, face as well as fingerprint, false acceptance rate, it is more compared to iris biometric trait. So for example, so normally researchers, so our researchers aim to reduce false acceptance rate, but it is very complex job. So now challenge here, how to design or develop a system. Okay, so here we should reduce false acceptance rate. So now later researchers thought, why we go with only unimodal? So here I am merging both unimodal, multimodal. So don't think I am going with only unimodal then multimodal. So wherever required, so slides prepared that way only. So now here, see whenever, so some cases, we are thinking why can't we go with so all these biometric traits? So such where we used this one in India. Can you tell me that is fingerprint, face as well as iris? In one of the database, it is Aadhaar. It is publicly it is not available, but say here each person's multiple modalities are stored. That is to identify individual, multiple modalities are used. That is fingerprint, this one face as well as iris. It is a 12-digit unique identification number which is given by Unique Identification Number Authority of India on behalf of Government of India. So as of 2018 November, so almost total 122.9 crore Aadhaar cards are issued. So for further updation here, we can visit the portal UIDID. This portal is given here. So just now, see here, just I told unimodal systems using single biometric trait, we can develop a system to identify the person, as well as multimodal traits can be used. But still we are facing problems. So let me first tell you what are the challenges we are facing in case of unimodal systems. It is uncooperative user. So what do you mean by this uncooperative user? Just now I told. So for example, iris, or for example when you are monitoring a criminal, okay, so that time is any person, okay, a suspected person. So when he come to the camera, he won't give his face that in structured environment, right? So he may close his portion of the face, okay, that is called uncooperative users. As well as iris, as I told, okay, people are really scared to give iris, so while capturing iris image, they are little bit worried. So that is the case. Unconstrained imaging conditions. For example, occlusion, that's what, only portion of the image is available. Always, why all these challenges are there? We are not capturing. If it is captured in well-structured environment, where is the challenges, right? So that is here, See now when we capture the image in unstructured environment, so some portion of the image is missing, okay, or variations, I can capture the image in dark room or in too bright room, or a portion of the image is too dark or portion of the image is too bright, that is illumination variations are there. Image quality, so while capturing image may be having noisy, that depends on your sensing device also. So it may be you may get the clarity, that is the resolution is good resolution, as well as, so now it is sophisticated devices, sensing devices are there. There are no need to worry about the image quality, but we should take care of noisy data. Inter-class variation, intra-class variation, same person with pose variation or expression variations will be there. Inter-class similarity, that's what is two people, even one case is twins, another case always we may say she looks similar. Today morning I told Bharati madam is almost looks similar to our Harshita madam. The face structure in the first view, no? So when I see her in the car morning, so I thought it was Bharati ma'am. Later, the other features we will consider. Then, because it is human vision system, but computer vision, how it will decide. Okay. Attacks on biometric system. Another challenge is we are trying to fool the system. So, for example, I can use mask, okay, 3D face mask, or I can capture the photo. I am presenting that photo to the camera. Or I can use cosmetic lens, okay, various types of lens to iris. So these I am trying to fool the system. That is also a challenge. Then user privacy. For example, some category of people, they are not ready to expose their face. For example, they cover with a cloth or a mask. So they never allow us to capture the image. Okay, so in that case only a few portion, even sometimes it is not only the face, even that eye region also it is covered. So not even, it is not possible to take that portion also. But still, that sparse representation is there. Even most of the data is missing, so we could, that is possible to recognize the identity of a person using sparse representation or sparse representation technique. So to design such or to address these challenges, we need unique representation and robust matching system. So let me present you pictorially these challenges, that is intra-class variable. We will get clear idea. Why I am concentrating all these, here it may not, sometimes it may be a redundant explanation, but I am trying to give for the beginners. So almost in the literature review part will be over here. Then even those who have completed, for them at the end of the discussion I have given the objectives also. So next generation, what are the unresolved problems are there that you can take up. Okay, see here different expression pose, Aishwarya Rai with the different variation and pose. See, for example, what I am trying to say here, see, in this case, for example, one place, let me take here. So this data, that is, for example, V1 intensity value in the position X and Y. So if she, that in the orientation part, or see here orientation, so same value in the X and Y position, am I getting same intensity value? It is obvious, see here 100% it is not. So we are not getting. Now challenge here is define or design a transformation function, so which maps these two images on same n-dimensional space. So that is the real challenge here. So next one, let me intra-class variability, that is aging problem. Here, so with this images also, a data set I have taken from, it is courtesy of Professor Anil K. Jain. So he was arguing, one of the session I was there, he was telling, see, when she was in 1995, so in 1998 it is score is 0.99. If it is above 90%, okay, that is acceptable. See, when age goes on increasing, 99, 2003, 2005, that score, matching score level is less. See, here your face recognition system will fail. So that is why in this case they will go with fingerprint biometric trait, okay, to identify a person. Inter-class similarity, that is for identical twins. See, here it is very difficult to differentiate twins, as well as those two members, celebrities. You can see, one is Divya Bharati, another one is Ramba. See, it is almost similar. right? It is very, even our vision system, human vision system fails. Okay, these are the challenges. I told unconstrained and aging problem. So I told here, see this is first one is, so for this is the structured environment image captured. This is the occlusion. See, this is covered with as well as expression variation is there. Same person with occlusion, expression variation. Again, this is the occlusion problem. This is also occlusion problem. This is illumination variation, orientation problem. Okay. Similarly, this is aging. So Albert Einstein, so when he was young and so when he was old, so the difference. Obviously, here face recognition system will fail. But in some extent, we could resolve these problems. For example, next in the discussion it will be there. If it is well structured environment, it is the well-known algorithm, all of you aware of that, principal component analysis, it will give the 100% result. Even with the slight minimal variation from the structured environment. That is, we tested, we conducted experimentation on that. So 5% variation or with minimal noise. So there still it is working. PCA is giving 100% result. But for example, this is a slight variation, it is 90% orientation is there. Then again it fails. Or occlusion, only one half of the portion is available, face portion, again it fails. For that, so we are, this is PCs, that is a global method. Okay, so next we have gone with other texture related algorithms, that is called local binary pattern. Anyway, that I will discuss in detail. Next slide. Okay. Another challenge is fake or spoof biometric input. See here, in this case, see this fingerprint is taken with the different various materials. You are presenting this to the scanner, right? See here face, that it may be a print attack, you are taking the print out of the image and presenting to the camera, or replay attack video, you are taking the video capture and that is showing to the scanner, camera. Then 3D mask attack, okay, that mask, she is wearing mask, see, it is similar. See, they are trying to fool the system. Similarly, say here also in iris case, see here, this is print attack, taken print out. See here cosmetic, that's what I told, lens with the glass, okay, with the other materials, plastic and etc. So that's what I am trying to say here. So this is the structured environment, both face. Here my concentration only on today's discussion, I am concentrating only face, fingerprint, iris. At the end, one of my students' work is there, that is palm print based person identification that I discuss. Otherwise, it is on these three modalities only. See here, this is the structured environment. Why it is called constrained to unconstrained? When you go away from this, see here, all sort of background is there, even illumination variations are there, expression variations are there. See here, compared to this, this is very challenging, right? So this is captured from distant, okay? So this is actual, so segmentation, only segmentation part, it is very easy to segment. But here, see, segmentation also challenging. See this case also, this is orientation problem. Again orientation in the signature. Again problem with this iris. Similarly, more complex images, see here. That is face, fingerprint on knife, okay, as well as this iris. Okay, let me come to these three biometrics, that is face, then followed by fingerprint and iris. So let's here in brief I am explaining. So what are the developments? Because my topic here, multimodal biometrics research progress. What is past, present and future? Okay, just let me quickly go through that. So face biometrics here. So in case of, in 1964, that is Woodrow, he introduced, he thought as well as that automatic face recognition, so he was thinking, but it was not implemented, materialized. Okay, later in 1970, see here upper part, this one all technologies, improvement from the 1964, that is algorithm developments in the face recognition system. Okay, so that is considering the face, that is unimodal. So down here, these are the sensors, okay, capturing devices developments. See here in 1973, again, see he considered only geometrical features. Then only that is position, where is the nose, where are the eyes, okay, then compared with that is graph is used, that is graph matching technique, very simple technique. But in that case, if you change the pose, then this system will fail, okay. In 1991, again, if you capture image in a well-structured environment, one more, that is called breakthrough research, that is Turken-Pentland, that is eigenspace, that is called PCA, principal component analysis, is used for face recognition. Then local feature analysis introduced by in 1996. Then in 1997, so that is graph matching, that is elastic bunch graph matching technique was introduced. Then face detection, then followed by recognition, that is Violajon algorithms. Here HAR features are used. Okay, so then after that, why only we go with, see here, this is the global features are extracted, right? So why only we go with this one? Let us go through the texture data. So face is having texture data, fingerprint is having texture data, so as well as iris is having texture data. So it is well suited algorithm for iris recognition system, to design and develop iris recognition system. See this one, sparse representation I am telling, so most of the data are zero, that is not available. In that case also it is possible to identify or recognize a person, okay, by using sparse representation. Now at last, so whatever, whether it is unimodal system or multimodal system, ultimately it is ended up with by using deep learning techniques. That's what in morning session completely it was explained. Here just I am giving glimpse of deep learning techniques. See here, in 1915, see here still camera used, then the digital camera in 1991, similarly, the later surveillance camera, then first camera on phone introduced in 2000, then RGB, that is Kinect camera is introduced, that is here depth information also can be captured, that is introduced in 2010, 13 and 14 wearable camera, that is Google Glass. So then unlock the mobile using face as a biometric trait, that was introduced in the year 2011 by Samsung. Then Google and Intel smartphones are, that is here along with the two-dimensional data, depth information can be also captured. So that is in the built-in facility. Similarly here wearable camera, that is in the year 2015 plus onwards, this is available. So that's what I told. So one more, the breakthrough research on face recognition system, it was principal component analysis. In 1991, they introduced, it uses the statistical approach to reduce the dimension. I think all of you familiar with this. Just to summarize that given data, okay, the image, okay, this is two-dimensional data is converted to vector form. Okay, so then you calculate mean and standard deviation for each feature, then compute eigenvalues, compute covariance matrix to identify the correlated data, correlation between the data. Then you compute eigenvalues and eigenvectors of the covariance matrix to identify principal components. Then sort eigenvalues and corresponding eigenvectors. Then sort eigenvectors associated with the discriminant eigenvalues and form the matrix of eigenvectors. At last you are projecting the original matrix on the eigenspace. That's what I am trying to say here. So with in the beginning only I said, so only all information is available. Complete phase information is available. This works, this is the best algorithm. But see if slight illumination variations are there, okay, then this algorithm fails. In that case, which is the most suitable algorithm? That is local binary. I am trying in the previous case, so one structured, now it is, this is, that is used to address the problem of illumination variation. See, local binary pattern which extract the texture description. So it is having, say, I think most of the students are aware of this, that is thresholding and encoding part. Thresholding gives us information about the local binary differences. Encoding part is this step encodes the binary numbers and converted into the decimal number to characterize the structural form. Then we go with computing histogram. See, it is a very simple way is explained. So see, this is the central feature of pixel under processing. I am comparing with its 8 neighbors. If it is greater than, this is the threshold, okay. Neighboring pixel is above this threshold, make it 1, otherwise 0. So these are the weights given, matrix with 8-bit number for representation. Then we go with the convolution, that is component-wise multiplication. So this is the representation, add it, so we are getting the LBP code. Okay, so this 146 is replaced in place of the C. Okay, similar, once you obtain this, go for computing histogram. In some cases, okay, so for example, only portion of the data is available, then we go with this, that is block-wise LBP. So we compute local histogram, then we are concatenating the histogram. So another variants of LBP is available. So we tried with enhanced LBP, local ternary point, local local ternary pattern, local directional pattern, that is extended or enhanced local ternary pattern. All variants are there. Every improved version of LBP gives better accuracy. Through the experimentation we proved. In the end of this session I will show the result. Just now addressed the problem of elimination variation. Along with that, say if orientation happens, okay, say oriented image capture or noisy image captured or occluded image is captured. So how to address this problem? For this, one more robust algorithm is introduced, that is local descriptor based face recognition, that is called scale invariant feature transform. It was introduced in 1999 by David Lowe. So what it see here, for given image, input image, we are computing that smoothened image. See here, Gaussian filtered image by varying sigma. This is the parameter. Then we find edge images, that is difference of Gaussian. See here the subsequent here, difference of this Gaussian filtered image taken, that is difference of Gaussian. Here we get edge image. See now how to get localized, that is key point. So for example, this is for example my target difference of Gaussian image. This is the L1 or this is L2, for example. This is lower level DOG, upper level DOG. What I do here, this see for here, for this pixel, it 8 neighbors. Same way I take here also, so total 9, here also total 9. So from this, which is the highest value, that will be replaced here. That is my key point. For that I am taking for that key point I am considering 4x4 region. Okay, then I go with the computing gradient calculation. Gradient means here for each point I am computing orientation and magnitude information. That is called gradient calculation. Then I go with computing histogram. So these are the feature vectors. So this algorithm addresses all sort of challenges, that is noisy, occlusion, elimination variation, translation, even orientation problem. Okay. So, but the problem is, see here each key point is represented by 128 values, that is feature vectors. But computation complexity is increased. That's what again I am telling, we are not at all worried about the computing devices. I am worried about, we are worrying about only accuracy. At last we come with now, after that, so now face recognition based on deep learning algorithms. So morning, sir already in detail discussed about all these. So most commonly used AlexNet. It was introduced in 2012. So these are the algorithms. Okay, so here, so these architecture is used. These are the methods introduced. Okay, so here various deep learning architecture, that is AlexNet, VGGNet, GoogleNet, ResNet or SCNet. All these are introduced. What I am trying to say here, I am not discussing in detail because just I am trying to say you can customize this architecture. So by changing the number of convolution layers, now filter size or various activation functions can be used, or different activation functions can be used. Padding, you can either go with zero padding or pixel replication technique can be used, or pooling technique, say either you can max pool or average pooling technique can be used, or various standard classifiers can be used, SVM, logistic regression or KNN, or even Euclidean distance can be used along with the fully connected layer. Okay, so you can change, otherwise all are using for all applications, all biometric traits. So to identify person, so we are using all these techniques. But so if you vary this architecture level, so it is possible to achieve the expected accuracy. So now let me quickly go through the data sets. So to publish, once you do, one of my professors, he was telling there are 3 types of research. One is simpler way, because beginners, so we can study all these, literature review you do, literature survey. Okay, let me, so for example, I am studying face recognition system. Okay, so same techniques, why can't I apply with for other biometrics? Iris, I can. For example, I am telling earlier, it was around 10 years back he told. Okay, so we can try with other data sets. Okay, so where are real data sets you can conduct experimentation. Normally we give this problem to actually BE final year projects. Similarly, when you come to next level, so researchers should cross these levels, right? That's the step 1. In the step 2, either you can go with now combine a hybrid mode of the techniques. So, for example, I did my work first PCA implemented, then SIFT implemented, then I thought, so here SIFT, it is having so many feature vectors. Why can't I reduce the feature vector size? Then anyway, dimensional reduction technique is available with us. Added SIFT, embed with the PCA, input of SIFT given to PCA. So it was giving excellent result. That was the first paper as I published in a reputed journal. So next, that's what I'm trying to say here. So in the literature, they have given, so you should conduct experimentation on these data sets, standard data sets. Along with that, if you conduct experimentation on real data set, it is well and good, but anyway, we are not getting good accuracy, but so we should think on improving the algorithm to get better accuracy. See here challenge same person with, see wherever in the crowd, where is she with this expression change, pose change, okay, occlusion problems, see here. So now this data, most of the researchers conducting experimentation on this data set, face data set. Similarly, so another mobile data set. See here, this is the combination of audio and video. So this is 150 people audio and video taken, the mobile data set. See here, so this person, we are monitoring this person. See his variations here. Is it possible to recognize? Only small portion is available. You have such a complex data. See here, image. So here also, see even illumination, very dark, right? So here only portion is available. Here even not even portion also available. Also one that is the sparse representation is better here. So that's what we have to think. So which all see here, this is the more complex data. See, same person in various conditions. See, similarly this one also similar. But people are working, it was already worked and obtained good accuracy. So to publish in the reputed journals, so in ICPR and so even another one is so those conferences, they are expecting your article, research article along with the code. So they run your code, they execute it, and they will genuinity they will check whether, because now everything is available in the internet, right? So if you go Kaggle, right, website, how many, so all algorithms along with the code it is available. But see, we so taking this result and publishing the paper or some other biometric traits, it is not encouraging. That is research ethics is there. So that is why, so if you conduct go through the literature, so even if you publish a paper one in 2 years in reputed journal, that is more than sufficient. In indexed journals, instead of publishing many papers, but some constraints are there in colleges, so we need to publish at least Scopus indexed journals. So this image is taken from the IDEAP Research Institute, Switzerland. Similarly, so another data set. This is most of the researchers so using in face recognition system. Experimentation conducted on this data. See here, so, for example here, see very challenging. All sort of challenges are there. So how to, so for these cases, even data set augmentation or data augmentation is done. That is why we go with here deep learning concepts. So can you tell me what is the reason? What is the reason? IGB, what is the size of this data set? Just for discussion, that's all.
Lakhs.
Around 320 plus GB. 320 plus GB, almost 350 GB data set size. So still data augmentation is done. They are increasing the size. What they do, so they take this image, even 5-degree orientation, okay, so they generate data. That is called data augmentation. Okay, then again it is increasing size. See, if you, anyway now our deep learning algorithms are there. If you input the data, so obviously we get, the computational complexity is there, so we get data. So how it is done? Because all sort of training is done, all levels. So that is why the deep learning that algorithms, it takes time, it is complex, only in terms of time, not accuracy. So next I'll come to the fingerprint. So let me go through this fingerprint biometric trait. So I told in case of interclass similarity, so we go with this, as well as in aging problem, to resolve aging problem. So we prefer this one, fingerprint biometric characteristic. So it was started so long back, okay, so China for fingerprint to seal the contracts and legal documents. Even we used to do that one, right? So thumb impression we were taking, okay, then matching is done whether thumbprint is, not now, around 30 to 50 years back, as you see the documents, the land records, we could see the that impression, thumb impression and all. Okay. So later, in 1988 is that Henry Flords, the article on fingerprint published in Nature. Then in 1893, so where these products are deployed. See, Argentina, first use of fingerprint as forensic evidence. In 1924, so that is FBI, US, they used for criminal identification. So similar here also, so they are used for, that is automated face, so fingerprint identification system. This is the next generation identification. So both, so here it is used to deploy to identify the criminal. So these are the various researchers' contribution. In 1963, Michel Turing, the first paper on automatic fingerprint matching, it was his contribution, Michel Turing contribution. So 2009 onwards, that is other. So India, we are using, so this fingerprint, one of the biometric traits. So 3 modalities are used. Out of 3 modalities, one is the, one among those is the fingerprint. Okay. Even in US visit, so they also used, as well as in Apple, the payment through the smartphones we are doing by using fingerprint biometric trait. So what are the features considered? When I say it is fingerprint, so these are the features considered while designing a system. So here I am, how it is taken, all those things, the implementation point of view. So you have to do that. That is crossover core, bifurcation, ridge ending, island, delta. So all these characteristics are considered. So these are the various products developed. Okay. See here, this is the fingerprint biometric system that is contactless, because after COVID pandemic, so people are, they're reluctant to give that fingerprint, right? So in that time, so all these techniques are introduced. See here, for acquisition, that is through a 2D as well as a 3D fingerprint is acquired using various sensing devices. Then see here, fingerprint pre-processing. See here, it may be a rich orientation. So all these features are improve the quality of the input image. So filters are used in frequency domain as well as the spatial domain filters are used. For feature extraction, miniature based feature extraction, so for 2D as well as 3D it is done, as well as the comparison or matching algorithms. So we used for 2D as well as 3D data. Next one is the iris biometric. See here, as we all aware of this, so the false acceptance rate here very less. Okay, that is why we go with iris. Even it is uncooperative mode, people are very resistant or reluctant to give the iris image, but in most of the secured system, biometric system, we go with iris biometric characteristics or modality. So let me, one of the survey, I got this from one of the survey paper. So exactly, see here, if it is voice, okay, if you consider voice, false acceptance 1 in 500. If I take fingerprint as biometric trait, there are chances of 1 in 10,000, false acceptance I am telling, okay. If it is touch ID, 1 in 50,000. If it is facial, okay, the biometric characteristics or modality, that is false acceptance 1 in 1 lakh. Or see here, so even, see in 3D it is 1 in a million, okay. But if I take iris, that is 1 in 2.25 trillion, okay. But I am not having proof here, just I have taken, referred to some survey paper. Just what I am trying to say here is that is very, very negligible, that is here negligible false acceptance rate. So it is the very robust, okay. So we can use all multimodal, biometric based system. So one of the biometric trait is iris. Again here, so all these 3 levels, face, fingerprint as well as iris, I am giving the technology developments as well as the some cases architecture, some cases methods, okay, various algorithms. See here, in 1936, the concept of using iris patterns for human identification was thought. So before that, okay, sorry, so then 1989 and 85, so Flom and Safir, so they introduced this first iris recognition patent here, okay. Then this is well known, all researchers, they are familiar with this, okay. So this first iris camera, it was introduced in 1989. So next one, that is one of the iris scanner system, one of the earliest commercial iris camera, it is 1995. 2004, portable iris recognition device was introduced by the company Biometrics. Then they introduced, they are more into, say here that is vision and semiconductor technology, okay, they are more into that one. So the iris on move, while moving only your iris image is captured, that was introduced by Sanofi in 2006. In 2030, optics, they introduced this smartphone to capture the iris, okay. Then see here, this is the Delta ID in 2013, so all your mobile devices, okay, which is having to unlock the system, either 2013, normally it is face based or fingerprint based. So now in 2013 they introduced this one also, iris based, okay. Similarly, see various advancement in 1985, then 1991, John Dogman iris recognition patent, it was expired in 2011, afterwards it was deployed. Okay, 2002, the use of iris recognition in field operations, then in immigration clearance at Schiphol Airport, okay, in 2003 they introduced, then in Aadhaar in India 2009, in Mexico Aadhaar, that is national ID 2010, 11 Indonesia national ID, they are using iris. Where these are deployed, okay, just I am telling what in applications of this, okay, so where we deployed this system, just I have given the idea about that. Okay. Then what are the features? See here I am not reading all these terms, just we are capturing this, okay. So iris region, so that is, this is the pupil, okay, that is complete texture data. So LBP is more suitable and variants of LBP as well as deep learning concepts. Okay. So for framework for iris recognition, this is not only for iris recognition, so this is for any biometric trait. It may be a face or fingerprint or iris, palm print, any this one, okay, biometric traits. This is the framework, that is what is that, capture the image, then go for pre-processing, feature extraction, because here iris is taken, that is why segmentation, because my region of interest is this one. Okay, see here extra character space also captured, right? So I have to only eye region is extracted, that is segmentation. Then normalization. So why normalization is, that is why we do normalization? To eliminate redundant data as well as the minimize data modification error. Okay, that our madam. No, iris recognition system. Sharda Bhatt madam already explained in detail, I think. Okay. Then we go with the feature extraction. Okay. Similarly, in the test phase also, we are going with the same process. Then compare this. Okay. Either any one of the distance matrix. So you compare. Then that subject is identified. So history of just again I am summarizing this. So in 1985. Irises were unique to everyone was proposed. In 1994, first iris recognition algorithm developed. In 2013, machine learning algorithms used like random forest and naive Bayes. In 2018, that is deep learning approaches used like neural network and convolution neural network. In 2021 onwards, used advanced deep learning models like GoogleNet, AlexNet. Only here I have given summarized, in iris biometric trait I have given summarized literature review. So now let me some works published in the reputed journals. Quickly let me go through this. See here convolution neural network based module for iris recognition, because you know this complete deep learning concepts morning sir explained. So here what I am trying to say, this is the training phase. This is the test phase. The iris image is taken, pre-processing is done, then normalized, then the data is fed to the convolution neural network. Then say here, the threshold is fixed. If it is greater than threshold, that subject is identified. Okay, so it is very simple. Okay, initial work done by the researchers. Then, okay, along with that, I want to tell you for researchers, beginners. Okay, so what are the contributions? The various countries contributed while generating this data set. So this data set, that is the Chinese Kasia data set, iris data set, most of the researchers are using. That is the contribution of the Chinese Academy of Sciences. Then here, okay, University of Beira Interior. So that is UB iris data set is released by this one. That is from Portugal. Okay, then all these are released by well-known premier institutions and other well-known universities. I am not reading all these data sets, just to go through that for your reference. That is also very, very important. So to work on the morning, our sir told, Hemant Kumar sir told, whatever the technology you are having, so without data, so that is also very much required, right? So what are the challenges in, so here also, here just to go through this, I have taken images, iris images captured at distance. This is using mobile phones captured. So again, in all this I am trying to say here, this is Chinese, size is very small. It is, that is also challenging. Say here, spectacles they wore means that is the occlusion. So similarly, what are the challenges in iris data set? Okay, so how to address this? Now you have to decide the algorithm to address these challenges. Next, let me, iris images captured by multiple sensors. So here, same iris using two sensors, okay? Capturing devices are used. Similarly, iris images capture different types of, yes, contact lens, because I told plastic as well as glass, something, the various cosmetic contact lens they are using. So that is also, that is otherwise how to avoid, how to address that fooling the system, right, biometric system. So now iris challenges I told there. So now we are training the data, okay, so with this data set, then you are comparing against the trained data. Spoofing and liveliness data set. Just these are the property or courtesy of all the researchers. I have taken these reputed journals, so they have given these data sets, this their property. I just taken, copied and so just discussing with you people. Let me come to this multimodal biometric system. So all of us know. So here because unimodal system I explained, because one is fingerprint, separately we discussed face and iris. Now combination of these three. Okay, so that is called, to identify a person, we are using multiple modalities, that is called multimodal biometric system. So here, how to see in multiple, so integration of multiple modalities, see here, so, that is two features, okay, or traits captured by different sensors. Okay, similarly, see where are the modalities, multi biometric sources. See here, two biometric traits are used. Here, same with one is minutia, another one is texture. Here, multiple is same person's two fingers. So here, same fingerprint, so second time. Okay, so that is called multiple samples. See here, what I am trying to say, in multimodal biometrics, we are combining features of two biometric traits. We can go with fusing, either sensor level fusing before classification, either sensor level fusing can be done or feature level fusing can be done, fusion can be done. After classification, either decision level or, yes, score level fusion can be done. Okay, so that's what I'm just, this is again Anil K. Jain. I have taken this information from his paper. If you want more information, please go through this. Just I summarized this diagram. So before and after classification, how fusion is done in multimodal biometric system. So another one, because we already discussed about why I have taken this. This is IEEE transaction on PAMI, okay, pattern analysis and machine intelligence. See. We discussed this one principal component analysis. It was introduced in 1991 for face, okay, for face recognition system. See, in 2020 also they are using same eigen face concept. Okay, that is PCR, not eigen face. Here this is applied for palm and finger. Okay, eigen. See here. So can you see this, because it is just wait. Okay. Image pre-processing after capturing. Okay, image pre-processing is done, then sub-image extraction and normalization. See here, little finger, because sub-image, little finger is taken, okay, ring finger, index finger, middle, okay, similarly along with this palm information also taken. Okay, then you compute, features are extracted using PCA. See here, still now we are using, so that is a global features extracted using PCA, then we go with the matching. Okay, see here fusion, that is now, see here fusion at matching level. Okay, so that means here score level. So I obtain score here, so that is fed here from the little finger, that is fed to this one, fusion is done. Then that is given as the classifier. Why it is called 3-3 classifier? At least minimum 3 voting should be there. Okay, in this paper they mentioned. So here for threshold, that is up to you. Normally we keep 90% and above, then we can correctly classify, otherwise not classified. Similarly with another, that is enhanced multimodal biometry, another reputed journal. Okay, and actually why this is taken, when now if you see this one, you feel it is very simple, right? If you read the paper, say again, say you feel okay. So now what is there here? All these techniques, you are familiar with these techniques. Okay, for iris, okay, already Sharda Bhatt madam explained all this. Okay, so in iris pre-processing you have done, okay, localization, normalization and feature extraction. Okay, similarly for testing phase also. Then see in the matching module, see this is the our iris data set, this is finger print data set. Okay, so now matching the matching module here, that the fingerprint score is taken, here iris score is taken, then score level fusion is done, then taken decision. Okay, so when now like that madam is telling, you read the paper and present it like this only. Just go through the, now you get clear idea. So these all the block diagrams are taken from the reputed journals only. It is from 2020, 2021 and 2022, next one. Okay. Multimodal biometric recognition system using deep learning based on the finger vein and finger knuckle print fusion. See, this is a IET image processing 2020 paper. Actually, very simple concept. While telling it is simple, implement when it is come to the implementation part, it is really complex. When I say orally, we can say it is a simple concept, but understanding purpose I am telling at this stage. See, what we have done here, input data finger vein or finger knuckle print. So I am not taking both. That is why it is unimodal. Okay. Say here, that is either, if I take the finger vein, here also I am testing face, also I am taking finger vein. Okay. If I take a finger knuckle print, here also I am taking testing face also. That is why it is unimodal recognition system. Actually, this paper is explained in the next slide, but for that preliminary information they have given like this. The features are extracted. So here testing face features are extracted, then compare. Only one classifier is used here. Okay. The classification and matching is done, then recognition decision is done. Okay. So here any standard your classifiers can be used. So SVM or Euclidean distance. Here if it is deep learning, normally we go with the logistic regression or KNN or SVM. Okay. So any, because now all are available, built-in functions. Just you are calling that function and comparing, right? Okay. So any doubt here? Okay. Next, let me come to the multimodal. See here, same concept elaborated here. Input data, that is finger knuckle. Here finger vein is taken. Okay. Pre-processing is done. Pre-processing, this is always for enhance the quality of the image. So then any techniques can be used here. Normally we go with the filters, various types of filters, either smooth the image, okay, or segmentation can be done. Okay. Now feature extraction here. See, this one finger knuckle print. Okay, so that is FKP. That is given to fully connected layer, as well as see here. This is finger vein. Features are extracted. See, now fusion is done at where? Feature level. See, fusion is done at feature level. See now, so there is standard classifiers are used here. Then go with the classification and matching. Okay, decision is taken. So that is this fingerprint database is taken from knuckle print. Finger knuckle print is taken from Hong Kong Polytechnic database. There is vein, finger vein is taken from database acquired by Shandong University. In this paper, that's what they conducted experimentation on this. Next one is multimodal recognition system based on score level fusion. So what is the difference? Now you can tell easily, just looking at this diagram. First 80% same concept, see here, input data, yes, pre-processing, features are extracted. What is the difference here? Previous one feature level fusion, now it is score level fusion. See, now see here, the classification is done, classification, different classifiers are used. And one more thing is different classifiers, or you can go with the same classifier also, or different classifier, then that obtained score is given here, then further decision is taken. Okay. Now let me, before concluding this session, okay, let me give my student work. See, you recently published this work, proposed deep fuzzy SVM classification approach for the palm print recognition. See, people are working using palm print as the biometric characteristic or modality also. Just to convey that message, I have taken this paper. So Professor John from AJIT, he is my PhD student, research scholar. So he is working on palm print based person identification system. So what he has done here, for the given palm print, region of interest is extracted considering, because I am just giving brief idea students, because his work, I am just giving overall idea, because it is already published, I am not at all worrying, okay. So words technology, words thresholding or Kirsch edge detector and hand contour. So here I establish a reference system. Then to enhance missing data, I should get it, right? For that I am using fuzzy enhancement algorithm. Then enhanced input image fed to CNN. Then for classification purpose, we are using fuzzy nonlinear SVM. Okay. So then, so here experimentation is conducted on contactless palm print database such as IITD and PolyU2, Tanjay and Kasha databases. Okay, so this work is published in International Journal of Electrical and Computer Engineering Systems, Q2 journal. So November 7th this year only it was published. So this is the architecture, proposed block diagram. Okay, so no need to explain because various convolution layer. Okay, then say input is taken. Just so this region of interest is this one. Okay. So taken extracted using Wurtz method and Fish edge detector. This is the classifier. Okay. Now result it is compared with the recently proposed novel algorithms. So he has conducted experimentation on this. Okay. So now proposed method is giving better result compared to all others. So these are the deep learning techniques also as well as traditional machine learning technique also used. Okay. Then his that is equal error rate. So always expecting if it is equal error rate is less, that is the one of the parameters to evaluate the system whether our proposed system is performing better or not compared to already proposed systems. Okay. So here is which gives less compared to this, or here or there some that analysis yet to be done. But when compared to all this, that is equal error rate is less. That means performance, your system is performing good. That is the indication. Next, here also genuine acceptance rate also computed. So here this one, this is almost equal to 1 means that is 100. So if it is 1, always we are expecting 1 or that is 100% genuine acceptance rate. So then that means, see here, that is compared with all other well-known algorithms, palm print based algorithms. Okay, this gives better result. Okay, proposed method gives better result. So extended work also we already communicated to the journal, that is a reputed journal only. So we received review comments, this good comments only, but we need to address all those things. Because I am not, so we are not here, so research ideas we should share. So I am also getting some input from your side, even though we are the research supervisor, we need, okay, that exchange of information is very much required. So that is why I am sharing my data also. So if you are having any suggestions, so it is, I am also very happy to receive it. Okay. So this is again various data sets. Genuine acceptance rate is computed, okay, with the various data sets. Okay. Similarly, another student, that is Professor Sucheta, she is working in SDM College of Engineering, Dharmasthala, Ujire. So she is working on multimodal biometrics. Now recently she proposed, already few works already done, but here what she has done, that customized model, that is the improvement is done in the AlexaNet model. So 5 layers she considered, 3 convolution layers, 2 fully connected layers. Anyway, for classifier the softmax only used. So image size is taken 68 into 68. This is the architecture. So obtained result when it is compared with the unimodal system as well as multimodal system. So it is not reaching 100%. Our expectation is it should reach 100%. Okay. So here also it is compared with the traditional machine learning algorithms, LBP, LTP, blockwise LBP and the blockwise local ternary pattern. Okay. So here also around 98% reached. So even comparison of multimodal system, so with the traditional machine learning algorithms, multimodal using traditional machine learning algorithms. So here it is almost 98.5, 99% reached. Okay. So what she thought later, so now, this customized CNN for AlexaNet model, so using unimodal, so it was not giving, actually it is lesser than previous one, okay, existing standard architecture. Okay, your customized CNN is not, we are not getting the improved result. But this is for unimodal. What she thought, why can't we go with multi, that is fusing the features. That is why, see, we have taken face and fingerprint, 2 modalities. So LBP is applied for face as well as fingerprint. CNN features, applying CNN features are extracted. That is modalities are used face as well as fingerprint. So these features are fed to the, that is, see here, CNN also considered for extractive features. The feature level fusion is proposed, that is LBP plus CNN. If I take only CNN, so we have not reached 100%, but 100% means nearer to 100%. Okay. But when I go with, so we go with LBP CNN, further analysis we need to do, but as of now, so obtained very good result. Okay. So that's what here, see. So now expert result of unimodel using hybrid approach. So then we go with, say here it is less compared to this one. Here test accuracy is better than that one using hybrid, multimodal using hybrid approach. Similarly, experimental results on some multimodal using hybrid approach. So better accuracy. Okay. So we discussed about various challenges in unimodal system. Still, see, even though we designed and developed multimodal systems, yes, all level accuracy we know. So it is accuracy is our expected level only. So better accuracy when compared to the unimodal. But still challenges are there. What are the various challenges? Why, so I am having doubt. Which biometric trait? Shall I go with the palm print and face? Shall I go with the fingerprint and face? Biometric traits. See here, which biometrics are going to use? For example, in multimodal here, face as well as fingerprint is used. Is it possible face and palm, or is it face and iris? Which is more suitable? That one, so through the experimentation only we should, so that depends on the challenges also. Okay, then level of fusion for multiple modalities, whether it is the sensor level or feature levels or a score level, so that we have to decide here. So these are the challenges, because see here some cases we go with the feature based, some cases it is score level fusion. So that's what. So here through the experimentation only we came to know which this performs better. Then we analyze the result. Okay. Then feature representation and matching techniques. See, we can use, because we have gone through many feature extraction as a representation and matching techniques, which is the suitable technique. It is choosing the suitable feature representation and matching techniques, and demand-based compromise between authentication, performance, computations and cost, obviously, because in multimodal, so we, when compared to it is unimodal, it is expensive only, computational expensive too. Okay. Then storage space required for templates. It is a challenge, more size, more space is required. So what are the advantages? So improved overall accuracy, obviously, when compared to unimodal, that is through the experimentation also it is proved. Okay. The systems are more reliable. So it tackles problem of universality and protects against spoof attack. Multimodal authentication provides more level of authentication. Okay, so obviously it is all these things discussed in detail. So then what are the expected, that is future scope in multimodal biometrics? So to identify a person using multimodal traits. The design of, because here experimentation is conducted on standard data sets. Challenging is conducting experimentation on real data set and getting accuracy. That is 100% accuracy. Obviously it is more accurate result. So that is why instead of standard data set, obviously in standard data set we are getting almost in previous, that is standard data sets, architecture, the deep learning architectures we have gone through. So we obtained 100% result. Then here problem is when we conduct experimentation on real data set, is it possible to obtain 100% result? Okay, it is not only 100%, nearer to the 100%. Okay, we obtained result. Then selection of appropriate biometric traits. That is in challenge also, as I mentioned. That is up to us. Okay, so it is not only one person. It is many people can take these objectives, and you can try with So even in the first case as well as here, biometric traits, various biometric traits, fusion strategies, and redundant elimination in the extracted features. Then implementation of this method, biometric, multimodal biometrics, in parallel computing units such as FPGA card, benefiting from both parallelism and pipelining processing, and testing the feasibility of the multimodal recognition system. So these are the expected, that is what we thought after analyzing all this. So these work can be taken in future. So with this, again, first two approaches we already discussed. That is, one is first level research is studying existing method, that is literature review, conducting experimentational various data sets, standard data sets as well as real data sets. Okay, then compare the results as well as in various different applications, different biometric characteristics also can be taken. That is one way. Second one I already discussed, hybrid mode. That was, then I stopped. Now after learning all these things, the third one, last one is, that is the new approach. So you learn and forget all those things, now come out with the breakthrough research work. So that is what expected from this workshop. So thank you for your patience listening. Thank you, one and all.
You have output of different biometrics. During fusion, how will you come? Is it like will you check the accuracy of both these are similar, so the combined result will be higher? Or
no, through the experimentation only.
No, after the experimentation, you have the result of. Suppose if you have, how will you find the union of the two biometrics?
Yeah, see, if features are extracted, for example, two methods are used. For example, fingerprint. Okay, I am using LBP. Similarly, for fingerprint, I am using CNN. Okay, so these two features are concatenated. Okay, obtained features are concatenated. Similarly, for face. So it is so two actually in our experimentation, what we have done, first level we have done first fingerprint, then face is taken. Okay. So then after analysis, again we gave fingerprint and corresponding face, okay, same person face. So like that it is concatenation of the features. So then another remaining face is the same, accuracy calculation.
I thought it's like you'll find it separately and at the end by checking the results will you...
In programming only, so while severe features are extracted, then concatenating the features. Okay, then go for testing.
Okay.
Decision.
That means few of the face you are taking and few of the finger you are taking and concatenating.
Yes, in one work we have taken fingerprints. Okay, for example, 5 persons, fingerprints. Then same 5 persons faces. Okay, but it was not what we can satisfied result. So then again after discussing with the experts, then we changed our strategy. It's a person 1 face, person 1 finger, again person 1 2 face, then fingerprint. Like that it is concatenated. Features are extracted and concatenated.
Okay.
Yeah, there we achieved good result.
Okay. That means suppose you have listed 5 for face and 5 for fingerprint, 3 from here, 3 from here you are taking and comparing. Means go for the exam.
No, that is for which one you are telling? Testing phase you are telling or training? Training all we need to train now. Yes. Testing I am taking one sample, so that is yes, fingerprint and face, then compared against the stored data. If all matching is done, yes, with all stored data.
Okay.
Wherever I get minimum distance, so there I tell that person belongs to that class.
This concatenation, like how you are concatenating the feature?
Matrix form, it is data, that is phase features are, now it is vector form, it is stored in the vector form.
Okay.
That is vector comparison. Same, so whatever, so normally what we do here in the training phase, so we till our feature extraction, okay. So that is in the vector form. Okay, see we are storing, right? So image 1, 2, 3, 4, 5. Okay, n number. Similarly, for the given input test image, okay, for the test image, what we do, same process is done till feature extraction. So that vector is compared against all data stored in the face data. For example, if it is face data is compared. If it is finger. Obviously, if it is compared with the finger, distance is more.
There should be one data
Finger and
distance.
face not possible. Finger to finger.
Comparison will be done with the only unique thing, no ma'am? Either it should be a fingerprint or it should be a face recognition. Because here we are
Finger with the
discussing.
finger, face with the face.
Yeah,
Yes.
that's why I am asking, because what happened, multimodal means there we are comparing face, finger, gait and all these things together, no? That's why what will be the final result we expect? That should be our question. When we are discussing about the multimodal, all this comes around. The data will be either it may be face, finger, gait or ear or something.
It is same person finger and face, no? Same person finger and face. While testing face also I am giving multimodal face as well as finger. That is compared against the 5 persons face and finger.
Okay. That should be
Yes,
same
yes,
face,
yes,
same
yes,
finger,
yes,
same
yes.
person.
Same person.
Madam,
Because,
I have a question. During thing that is authorization, we are working on multimodal authentication. What are the kinds of attacks that we can expect? Types of attacks, because it's a kind of an authorization, because just to increase the efficiency of the system, in fact, nowadays we are going for this multimodal authentications and all. So only one thing I know is presentation attacks. Other than that, what are the other types of attacks that we can expect?
Imitating is not possible. Only that various types of presentation attack or other types of attacks are there. No? So even fingerprint same. That is fooling the system. So what we spoofing. Okay. So we are trying to fool the system. So with various cosmetic eyeballs, lenses, various even artificial eyeball also available. Or for example, in case of face, so with this one beard and your look is one is like totally. So I don't know whether I should mention here, like our father in Christians, here priest in Hindus, in Muslims again. So that various what makeup, even makeup also.